In today's video, we are gonna check out piezoelectric transducer. I will be covering a topic like how they work, their construction, advantage, disadvantage, and application. It's really exciting. So, an electric transducer is a device that convert pressure like the pressure we apply into an electrical signal. It is used to detect changes in acceleration, pressure, strain, temperature, and more. It converts force into electrical charge, and that's what we use for our measurements. First off, check this out. This electrical material act as a transducer. So if I switch it on or press it, it will convert that pressure into electrical charge, right? The voltage here function based on the force and pressure applied to it. So we will use that pressure for our measurement. Now looking at the construction, this piezoelectric transducer consists of. So how does a crystal stay as a crystals? Okay, if we look at silicon dioxide in its crystallized form and use it, this is what we call a piezoelectric material. When we apply a force to this crystal, it generates voltage, and this is what the crystal looks like. It's not exactly symmetric, but we only need to use a very small part of it. That means it remains electrically neutral, meaning if I don't apply any force to it, it stay completely neutral at zero. Okay, so they are going to produce this for us, but as soon as we apply force, it generates some charges. This piezoelectric crystal or predictive crystal can be shaped differently with various materials. So it can be really small, and we can extend it up to a few centimeters in size. So basically the working principle is that when we apply mechanical states, it will generate electrical charges in the crystal. In a normal situation, if I am not applying any stress to the crystal, it's all good. But when I apply a compression, you see we have got positive charges on the side and on one side and negative charges on the other side. So when I pull on the crystal from this side, the side that was previously positive, okay, previously positive turns negative, and the other side become positive. Okay, similarly the more pressure I exert, the more this effect happens. So the pressure of EMF is proportional the pressure of EMF. Okay, when we apply some pressure here, it's like work like suppose squash type of things. If you pressure it in a dropper, if you pressure it, it is squeezing. Okay, like that. The pressure of EMF is proportional to the pressure applied. That is why we can use a piezoelectric crystal here to measure pressure. As I mentioned earlier, if I press it, it generates charges on one side. Similarly, if it gets compressed, it produces charges in the exact opposite direction. This is the working principle we use. Now see, this is directly proportional to how much pressure you apply. The more you press, the more voltage is produce. So from here from there we can, okay, if we can convert it into a precious scale, then it say here that it will be a function of the force and pressure applied to it. It can let us what the force is based on the voltage reading. So we can replace this reverse reading with force or pressure. In this way, physical quantities like mechanical stress and force can be measured directly using electric transducer. So that the working principle of electric transducer, let's check out some example of piezoelectric materials. Okay. Earlier, I mentioned that the name uh, could refer to either the baby or the leads uh, something. So with all this material, we can take a look at the application for the electrical materials. This material will be used many places, especially in mobile microphones or camera microphones. It can also be used in automobiles, and we can even use it in electrical signal. Okay. uh, Electrical lights, it produces a spark in a certain way, and then we can use that gas here. Similarly, the same lighter materials we used in infertility treatment, mm, uh, and medical diagnostics. So they use electric materials where there is no need to external forces. It directly provide voltage, and active transmission producer directly supply, and it's small in size, which means it's work really fast, and it can also identify rapid changes. Now if we look at some advantage, this material are not suitable for static condition because of the forces involved. It only produce output when you apply it, so it is not suitable for the static condition. The output can vary with temperature, so there is a limitation here. So those were all the points about our piezoelectric transducer. Thank you.